All right, we're going to continue our lessons on congruent triangles. If you look at the following triangles here on this page, determine which triangle congruence theorem, if any. Well, we only know a few, right? We know three shortcuts. Those are triangle congruence theorems. Side, 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 side angle side, and hypotenuse leg. Now, hypotenuse leg is only good for right triangles, okay? So if you look at number one, you can clearly see that it's not side, side, side. Is it side angle side? Side, angle, side is the angle between them, what we call included? Yes. And if we wanted to write a congruent statement, if I wrote triangle ABC is congruent to, what triangle would you say? ABC. Right, DEF. What about 2? Well, that looks like side-side angle. Is that equivalent to side angle side? And the answer is no, because the angle is not included. It needs to be up there. So these cannot be proved congruent. How about 3? Yes, side angle side, isn't it? So if I said triangle ABC, that would be congruent to triangle DEF. I'm just matching up the tick marks. And what about 4? I know most of you are going to say yes, just on instinct when you see these arcs. But here's the deal. There's no sides equal. Well, you have to have a side congruent in these 3 in order to use them, and there isn't. This would be angle, 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 but that's not a shortcut, a way to prove triangles congruent. However, we're going to add to our list. The next one we're going to add is called the angle-side angle congruence theorem, which is just what it sounds like. You have 2 angles, you have a side between the angle, and then a second angle that are congruent. Now this is the key word again, included. Notice where the side is in relation to the 2 angles. It is between them. We call that included. And the last one, the final shortcut, as we say, to prove triangles congruent is the angle-angle side theorem, AAS. Because it doesn't matter where the side is, angle-angle side is a way to prove triangles congruent, and here is why. Let's pretend for a moment that angle B is congruent to angle E. Well, if those are congruent, well, let me rephrase it. I know they're congruent. Let's go back to earlier. We learned that if 2 angles are congruent in one triangle to 2 angles of another, then what do you know about B and E? Well, you know they have to be equal, right? Because the angles add up to 180. Well, if that's true, then look at this. Isn't that angle side angle? So to avoid having to do all that work and thought process, you can immediately just say angle, angle, side. Notice the difference between this and this. On this one, the side is not between the angles, like this. But on this one, the side is. It is between, so we call it included. Now the next little exercise we're going to look at are these triangles. Can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. Well, here's all the theorems. Okay, we're going to see if one of these 5 fits with these problems. Okay, well, let's see. Yep, do you see the triangles? I do. I think there's a missing angle. We have these 2 angles, they're the same. We have these 2 sides. Do you see anything else we can say they're congruent? And I know you want to say these sides, but you can't assume anything. You can't just say, because it looks like they are. That doesn't work. You have to be able to prove it. Well, I know two angles that are congruent, and they're right there. And I can prove it because those are vertical. So would this be angle, angle, side, or angle, side, angle? Well, is the side included, or is it outside? Right, it's outside, so it's angle, angle, side. Okay, on B, I have all three angles congruent. Are there any sides congruent? Not that we know, do we? So I usually have everyone just say NEI, not enough information. We need more information. We need a side because angle, angle, angle does not work. Remember, it's got to be one of those five. And finally, this one. Let's see. I see two triangles. I see that these two angles down here, upper left, lower right, and then upper right, lower right are equal. So we have the angles. We have two angles. Do we have a side? Well, I know a lot of people would say, what about these two? They look equal. We can't assume that. How about these two? Those look equal. Well, maybe. We can't assume that. However, there is one we can assume. You're right. It's in the middle. They share that side. Well, if they share that side, then it is included between the congruent angles, here, here, and here. So that would be angle, side, angle, angle, side, angle. So it works. So this would be ASA. Okay, so here we go. Number one, can the triangles be proven congruent with the information given in the diagram? If so, state the theorem you would use. Okay, so we have parallel lines here, XW and YZ, and we have parallel lines XY and WZ. Well, this is why we learn all those facts about all these angles, guys, for this reason, so we can apply it. Well, angle 3 and angle 1 are alternate interior, and XY and WZ are parallel, so we know those would be congruent. But 2 and 4 are formed by YZ and XW, but they are also alternate interior. So they're congruent because the lines are parallel. So we have angle, angle. Do we have a side we can say for sure is congruent? Well, you can't assume any of these. You can't just assume it because they look like it. Okay? That's a fallacy. We can't do that. We can't rely on that. Doesn't work. You have to be able to prove it. Well, I can prove something. That side. WY is the same in both triangles. So if you look, the side is between the angles. So yes, we can say that these two triangles are congruent by angle, side, angle. Now, what would be your congruent statement? Well, if I start at WXY, what would be congruent to WXY? Because here's the thing, when you write a congruent statement for two triangles, it doesn't matter what order you put it in. What matters is the second part of that order. So therefore, what's it going to be? Well, WXY, W has two arcs on it, so we got to start with two arcs in the other triangle. So that would be Y, Z, W. And there's our statement, and there's our reason, angle, side, angle. This concludes our little mini lesson on congruent triangles. Once again, there are 5 ways to prove triangles congruent. Hypotenuse leg in right triangles, side, 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 and side, angle, side when you have two sides equal, angle, side, angle, and angle, angle, side when you have two angles equal. And that is it. Those are the only shortcuts or ways to prove triangles congruent.